Hey, Alfonso, welcome to Airhacks FM.
Hi.
Yeah, it's a short hi. So what was your first computer?
Well, I have this Intel something, Pentium something in the 90s. And then suddenly I started doing like Pascal and Visual Basic.
Okay.
And I remember it was Windows 98. Was in the old days.
Okay.
So I started doing Visual Basic and then moved to Borland Pascal, which was great at the time.
Mm-hmm.
And then do C++ and so on. Right?
No games. So you just started, it's like, hey, Dad, I really would like to have a Pentium to learn Pascal, right? This was the trajectory.
Well, I wanted to be a designer. I mostly did like more like the image pro, like Photoshop or like 3D Max, all this software to do 3D stuff.
PaintShop Pro. Remember PaintShop Pro back then?
Yes, I mean, yes. At the time, it was very basic, but you could do quite a few cool stuff.
Yeah.
So I wanted to be a designer, so I used more the image stuff than the games. I had a console, so I did game in the console.
Oh, okay.
So
Sony.
Yep.
Mm-hmm. Okay, and so you wanted to have the PC, for design work, and right? So, but how Pascal happened? So you need Pascal to write scripts for your PaintShop Pro, or what was the relation?
Well, I was in a school, and in this school there was a group, like preparing for the computer like programming Olympiad, this IOI, International Olympiad in Informatics, and the language they used was Pascal, so Borland Pascal. And I remember because the IDE was the console-based one. There was not the fancy Visual Studio, or even the new Borland had like a full graphical IDE. And then at the time, so we just used this console, like I remember blue and yellow console IDE, which was extremely good, extremely fast. So there I learned to code, program. So I started doing like basic stuff. And yeah, so that was the goal.
So you participated in competition. So
yes, so I for 2 years I dedicated almost full time to code, to learn how to program and learn a few algorithms. And then I participated in the IOI in 2008 in Egypt, Cairo.
Okay, and why you wanted to do this?
Well, I liked math. So in this group, there was other subjects. There was math, physics. Let's say that the computer group was the best one because you could, you have a computer for you the whole day. So the math, you have like a notebook and a pencil, right?
Okay.
Was great, right? But I mean, the computer guys were like, you were like in a more luxury station, right?
Yeah. And how you did in the competition?
Oh, not very good. I mean, for context, I was born in Cuba. I'm Cuban. So Cuba has like many different problems, and one of them that the internet at the time was forbidden. So there was no internet. So I was very limited, let's say. And so it was very hard to train for the stuff and to access any resources was very complicated. So let's say like the math books were very good, right? But the internet and the other stuff was not very good.
So I thought, then you are not distracted by YouTube and whatever was available back then. Now, YouTube was there 2008 already, I think. And but you could practice more. But of course, you didn't have the resources to Stack Overflow and stuff like that, right? So,
yeah, exactly. So it's complicated.
Yeah. But I mean, not very good, but it was still a good experience, or you were demotivated, or what was?
No. I mean, the theory was rather good. I mean, in this country, there's like tradition of. So we had very good textbooks, and we have. I remember like a CD, and in this CD, you get like a copy of problems for these competitions, all translated to Spanish, with solutions and stuff like that. So I mean. It was hard, but not impossible. And if you really wanted to learn, if you really wanted to to persevere, you could do it.
Because I learned Java before Stack Overflow. So I exactly remember when Stack Overflow came out. And what I also remember is I showed to workshop attendees the very first time Stack Overflow, and they were amazed. So, wow, there's something like this. So, and I learned actually from books. I really like books. I bought all Java books which were available back then. My first Java book was Java in a Nutshell, I remember, by David Flanagan, the very first edition. So, and later internet came, but I ignored that a bit because then if you know it. But of course, I was just Java is way easier than what you did with algorithms. This is a way harder, to find a book which describes, the algorithms. For me, it was easy because back then there were millions of Java books you could read, day and night, and it still was not over. So, yeah. Interesting. So, what happened after the competition? So you keep coding for yourself, or did something interesting with Turbo Pascal and Visual Basic? So, what you did actually with your knowledge then?
Well, I started university and continue in the competitions, and also went to this ICPC, which is the university competition, let's say.
In Cuba?
So actually, I was the first Cuban to go twice to this competition. You can only go twice.
Cool.
Yes, actually, so now Cuba has a rather strong tradition in this competition. So I started a team, and then this team inherited new members, and this new members got new ones. So basically, the tradition of programming competitions at the university, at this particular university, is very strong, and I'm very proud to be one of the founders of the teams, right? So every year I'm very happy because the students win the Latin American competitions. It's very good. I feel very proud for them.
Very good. So what I assume just that there is a sculpture of you, at the enter of the university, so the first Cuban took at the competition, right? Full size sculpture, from you. Looks like Iron Man Alfonso and the in the enter of the university. Say, yeah, this was the first Cuban taking part, and just kidding, at the competition. But how you did the second time?
Actually, not good either. But good enough. And as I mentioned, it was very hard at the beginning to start all this up, and there was no tradition. So I think for this stuff, you really need the tradition. So the way it works now is that every new guy that comes, so you learn all these algorithms, all these tricks, all this. So it's so much faster. At the time, we just didn't knew better, right? So. But anyway, it was very fun, and I would really enjoy it, and I think that's what I did for me.
What do you have to do in such a competition? So what were the questions to solve?
Right. So the format is that you get 12 problems, and in these problems, every problem has a described input and a described output, and you have to write a program to pass some tests. The tests you cannot see them, so you can only see some basic tests. You have to pass a battery of tests within a time limit, right? And usually to do so, you have to implement some efficient algorithm. You cannot exceed the memory, you cannot exceed time. So, and that was one of the reasons why the most common programming language there is C++, because then you really need to make sure that your program runs under 1 second or something like that. So. Yeah, more or less that's the format of this competition. So you submit the program, they compile it, and they run it against a bunch of hidden tests.
Okay, and in the end, this was I don't know what sorting, parsing, or what was it? Or
well, yeah, let's say it's a bit of sort. So, it's not exactly with one of the components, but there are so many combinations, right? So you have binary searches. There's a whole list of algorithm and their application. So it's not. They say maybe something like the late code hard problems will be something easy. Let's say. So usually the competitive programmers are very good at this late code and all these interviews. And the reason is because so that's what you do. And actually, if you train for that, then it's an advantage. But doesn't mean you're good in any other areas of software engineering or right.
Yeah, pretty cool. So you studied computer science then, I think, right?
Yes, actually, I studied in Switzerland. I moved to Switzerland and I did a bachelor's and master here. And then I started. I did an internship. I did 3 internships at Google, and then at Oracle Labs, where I work now.
At Google, how is Google?
Oh, at Google. I mean, when I was an intern, it was great. It was awesome. So
Yeah.
I
What
spent
you
the
did
summers.
there? So that's interesting. So, and by the way, so maybe university. So 4 years of your life, what you did there? So I mean, we know you did some. What you learned, programming languages, maybe some interesting project you did. No, what?
Well, when I was in Cuba, I did these programming competitions, which I enjoyed, and then I moved to Switzerland, and I got more interested in compilers. So I had a class about functional programming, taught by Martin Odersky. So
Wow.
And it was
Scala.
Scala.
Yeah.
Right. So functional programming, but the language was Scala, of course. And I really got very inspired and really liked the functional programming switch clicked on me, right? And I was like all Scala, trying to do everything in a functional way. So these days I'm a bit more far from those like functional programming stuff, but still I think it's a very nice. So all the concepts around. And then so I started to do these compilers, and I did these internships in the V8 team. On the V8 is the JavaScript engine in Munich. So that's how I started with compilers, and then I joined another internship at Oracle Labs, also related to compilers. So yes.
So you started at Google. You were the V8 in the V8 region, right? So
well, I did a bunch of stuff. So I worked on the Chrome for Windows. I worked on V8, and I worked on some Google Shopping infrastructure
in C++. I think you had to use it, right?
Yes, that's why at the time everything was C++, correct?
Okay, and then you said no more C++, and then you switched to Oracle.
Yes, so I did an internship at Oracle. First working on the compiler. And I completely was like, I really enjoyed all the group. I was part of the GraalVM team, the location, the office, the people, everything.
In Linz, where were they?
No, I was here in Zurich.
Okay.
In the tower. And so I was a student, and I was like, oh, this is the best thing ever, right? Mm-hmm. And then I did another internship, which was also interesting because this other internship was Espresso. Espresso is this multi-circular JVM written in Java.
Java in Java, so Java written in Java, which runs Java, right?
Exactly. So that was actually my second internship at Oracle Labs. And then
you did Espresso?
Yes, actually, Espresso was my master thesis.
Well, it's cool because in a podcast, I think I had already a podcast with GraalVM members, and they mentioned that the Espresso was created by a student.
Yes, that student was me.
Very good. So this is how the circle closes. So perfect.
It was me and my host, right? And actually the colleagues I have, because I was like a naive student, right? Mm-hmm. But actually, yes. So I was the student. So I got a lot of help from Christian Humer, from the Truffle team, and Jill was my supervisor at the time. So yes. Mm-hmm. So it was not like a super talented student coming and implementing this whole thing, but actually was a proof that the GraalVM and the Truffle stuff actually are make this very or easier to implement, right? So if somebody can come and implement something like that, then right. The tools they are using are very good, actually.
Sean Smith, I had that, Sean Smith.
Yes,
yeah, and he mentioned Espresso and was created by a talented student. So now I met the student, which is very good. So it seems like you enjoy compilers.
Yes, I love them. I mean, it's a very like nice let's say niche of the profession, right? So you have like the most general software engineering, and now you have all this AI stuff that's pouring recently. But compilers have always been like the things that works, and they have a very nice theory behind them. And basically, what we do is basically chasing all this theory, trying to make the actual compilers faster, and but I find it stunningly beautiful, the field.
back then in my study, I have to admit, I didn't like the compilers. It's like, okay, compilers already there. I just use them, to do something more useful. They are done. But now it sparks my interest because now it's something, different, which I usually do. So I appreciate compilers now more than back then because I was maybe too pragmatic. I just wanted, just to pick a Java and just start coding. So this was my idea. Okay. So very good. So you spend the time on the GraalVM compiler using the Espresso. Was it challenging, the Espresso project, or was it easygoing? Or
well, let's say so. I was a student. I wanted to do a truffle Scala. So implementation was Scala for truffle. But then Thomas Vertinger said, no, you should do like this Java thing because we had a few prototypes and they didn't work or we have some issues. And I was naive, right? Because this is the moment you say, yes, I will do it, right? But if I knew the complexity of what I was getting in, I probably would say like, no, I'll pick something else. But anyway, so I spent 6 months working very hard. And so you have to implement a VM from scratch. So the bytecode interpreter, and then you need to parse the class files, and then you need to... So there's a bunch of components you have to write from scratch. So yes, it was extremely challenging. So I had to implement GNI. I remember it was horrible, but yes, I implemented it in C and then some Java. And then, so the whole GNI implementation was there. And actually, I think it was the most challenging project I've ever done. But I'm very proud because now I see it like, it kind of works. You can run Minecraft on it, and it's good enough. Yes.
Mm-hmm. And is there a practical use right now? Because you could use with that Java as a scripting language, right? For instance.
So that's one of the purposes. So you can embed like dynamic Java in native images. Mm-hmm. So I wouldn't recommend it for running like huge applications. So if you have some bits of dynamic Java code or that you want to run, then you can just use it within the context of a native image. So that works great. Anyway, so we're planning like to add more useful features for security, so you can get like really like more isolation. Mm-hmm. One of the things that, like for example, like when the security manager gets deprecated, you can use Espresso alternative because you just found a new context, run whatever you want in that context, and if something goes wrong, then the context dies, and that's it. So it doesn't pollute the host VM, right? That's one of the ideas. Mm-hmm.
So the one of my use cases would be what I did, JDK 1.8 timeframe. I used the Nashorn as a scripting, as a fluid logic, I call that, because sometimes in applications we wanted to have like a flexible algorithm, which is not hard-coded. And what we did, we didn't want it to have JavaScript, but we had Nashorn. So the JavaScript implemented an interface. So I used from outside the interface, and the interface was implemented by JavaScript. So this was the hack. But Nashorn is no more standard. So I could, of course, use the GraalVM JavaScript capability, or I could use Espresso right now. And this is even nicer because now I can have a Java code, write a unit test, and after the unit test is written, I can just upload it somewhere, a database or whatever, right, and then use it on the fly, right? So I could have I could extend Java by a hook or plugin mechanism somehow, right?
Right. Yeah, that exactly is one of the use cases we have internally. So people using it like this just to run like snippets of code or user code, and in a let's say like more like confined way.
Mm-hmm. Yeah, perfect. Okay, then Espresso was done. What happened then? You stick with GraalVM team?
Well, it's not done, right? So okay. I remember by the time I finished, so it was 6 months. Espresso could run itself. That was one thing, and it could run Minecraft at like 2 FPS.
Uh-huh.
So it was the infancy, right?
Yeah.
So, but it could run it. I said, it runs, but like done, right? I'm done, finished. Actually, so after that, I stayed at Oracle Labs, and we continue working this GCK, is the Java compliance the test suite. It's like thousands and thousands of tests to certify that you are compliant. Mm-hmm. So we worked for a whole year, maybe, with my colleagues trying to get Espresso to actually pass all the tests. So these days, Espresso actually passed, I think, most everything. So because there's a bunch of tests that are like not even Hotspot passes them because it's not the right version or something changed anyway. But the huge majority of tests that you should pass, Espresso passes it fine in a few configurations. So these days, I'm not pretty much involved with Espresso directly. So I'm working on this debugger for native image. So you can debug your native images using the regular Java tooling. So that's what I'm doing these days. But I'm just waiting for this project to wrap up, to just jump back to Espresso and continue.
This is great news. This means we have JavaScript, which is regular Java, right? So you could run with Espresso Java applications without compiling.
Well, it's a JVM, so you need bytecodes. I mean, you could do like something like JShell or something like this, right? Where
yeah.
So, but the actual part where you input Java code. So Java was not designed for scripting. So it's very verbose, and you have a lot of imports, and you need to define a class path. So all this stuff is not very friendly toward scripting.
Except Java 22, right? So
yeah, exactly. So let's say like it's getting better, but the whole idea of the language was to be statically compiled to bytecodes and so on. So yes, you could provide your own way to compile Java sources directly, but the idea is that it's not as easy as JavaScript in this regard, let's say. So I would just, if you want to use Java, just use the compile jars or the compile bytecodes, and so basically what the user will chip will be the compile output of like the bytecodes, and then Espresso will execute it.
Okay. But what you also did, I found you integrated an LLVM into Java in one class, right?
Oh, this the LLama2.java thing. Yeah.
So, and I mentioned this in a podcast, and I get immediately lots of comments. Is it possible? Where is it? So, and I just pointed to your work, why you did it, how you did it, and I saw there are extensive, descriptions regarding the performance, how it performs, and So first, how you got the idea and how it happened.
So I was very curious about how these LLMs work, because suddenly you got this these models, you can do so many things, and I had a Telegram bot at home. So the Telegram bot is something you can chat, and it's connected to OpenAI. So and you have some plugins, you can do searches, and you can do how's the weather and stuff like that. So I really wanted to know what's on the other side. So what's on the model side. And I saw this project by Andrej Karpathy. He's like the Jesus of LLMs, right? So he's the guy, he's the goat. He's actually a very good teacher. He has these educational videos where he goes into detail how these models work, and he demystifies the whole thing. So basically, you may think, oh, these models are super complex, and there's a lot of, but actually the actual code you need to run these models is rather small and rather simple. Let's say you just multiply a few matrices, and it's not even matrix multiplication. It's just matrix times a vector plus a few normalizations and stuff. And actually, it's so I think the beauty of these models is the simplicity of the idea. And so I saw this project. He wrote this Llama to C, was a C version, a C port of Llama 2. Or some version of it, let's say, because it was
how he did it, you know it? Because what you are saying is, are we talking about Onyx format?
No, not exactly. So in this open source, so let's say Onyx is not that popular in the open source models these days. So people usually use this llama.cpp. Or VLLM. So there's other projects, and these has their own custom formats called GGUF and things like that. There's also the Hugging Face guys who also has a format, but it's mostly consumed from Python.
But Andrej, what he did is he ported from Onyx to C to the open source form.
I'm not sure what's the source of the port. Probably some Python something, and then they just unwrap all the the blocks, because the Python code is rather short.
Yeah.
It's just like you have all the building blocks, and you just need to translate those to clean C. And he did it in a way who was very instructive. So it's okay, like now we do this, and then this operation means this. So you can really see, read through the C code and see what's going on. So I decided I should try to import this to Java, because why not, right? So I did this port. Initially, it was like a one-to-one, so it was like straight port. And then I added some extras, like so you could do the matrix multiplications. I had added vectorization. Sadly, the Growl compiler still does not support vectorization, or supports a very limited form of vectorization. Because the vector APIs are still in preview or incubator, so it's still not real part of the JVM. But I added a few cases, so a few like alternatives, let's say, to speed up the matrix multiplication using the Growl's auto vectorization feature. So Growl is rather smart and will vectorize your code even if you really don't use the vector API. So yes, so if you write your code in certain shape, right, Growl will figure it out and will auto vectorize your code.
Okay.
So I added these extras, and you could so this problem of models is actually constrained by memory bandwidth. So the main limitation is not CPU. So I think after 8 cores, you stop getting any extra token per second throughput increase, because your memories are already saturated. So it doesn't matter how many cores you throw at it. You're just waiting for the memory to be read. So because basically every token you read, you infer in these models, you have to do one pass over all the weights in the model. So basically, imagine you have a model of 7 billion parameters, and every parameter is 2 bytes, like a small float, or let's say like 1 byte, let's say, because they have these quantized versions. Then you have to traverse 8 gigabytes for every single token. So every like tiny demi word you see in the output, you have to traverse 8 gigabytes of memory again and again and again. So, and this is a very very costly. So the community has a few tricks to shrink the size of the model. So you actually, instead of reading 8 gigabytes, you read 4, or you read less. It's called quantizations. So the only thing is that these models, like, then they lose some capabilities, because it's like you do some sort of you took the weights and then you ground them and then you transform them a bit. So the models are then not very precise, let's say.
Is there a difference to let's say the Apple M2 and M3, because they are different access to memory? Is this any advantage using this hardware?
Yes, for sure. So at least one of the nice things of Apple is that the unified memory.
Exactly.
So basically, you can map your RAM to your video memory, your video card, and use it directly. And actually, there's this framework that does exactly this. MLX, I think it's called. And actually, I think the model there is so much nicer. So I don't have a Mac. I use a regular Intel computer with Linux, and I have an AMD video card. Which, like for this machine learning stuff, the good stuff, let's say, like the good video cards are the NVIDIA, because where most of the support, so all the support is in those cards. And it's actually very hard to run these models or whatever, anything on AMD cards. It's always a mess. So you can do it. So actually, recently in these days, you can actually, so the frameworks to run the models are all support like this RockM software from AMD to run on the cards. But it's a pity, because the cards are actually very good, and they have, like, I don't know, 5x, 8x, 10x more bandwidth than your CPU. So if you could fit the model inside your GPU, then you will get instant, like 8x, as I mentioned. It's not the compute bottleneck, is memory bandwidth.
But on Apple an Apple would be CPU, right?
Yeah, exactly. So that's the same thing. So better hardware. Actually, the bandwidth of the new Macs are, I think, it's like 2x, 3x, 4x faster than the regular Intel CPU I have. So yes, for sure, the Macs have an advantage there.
Okay. So, but in Java, so you did it. So you ported the C binding code to Java. But what the C code did, it was the Python glue code, right? Which accessed the model, or what was exactly the C code?
Well, so let's say like these models have two components. One is the compute graph. So basically, the compute graph is just you here enters like an array of floats, and then you do some operations and you multiply by some matrices. So basically, every step is like this. So you do some operation, and then you get some output, and then you pass it to the next one. So this is what considered the model. And then the other part is the weights. So these models, Llama, this port, what it does is inference, but there's also the training, because it's in the other direction, right? So when you want to actually generate these weights, and the weights is this files of 8 gigabytes or more, depending on the size of the model. And then this C file, what it does, it just implements the compute graph directly in C. Using pure C, no like fancy APIs, no I don't know, CUDA or whatever, just a regular C. If you want to do a matrix multiplication, it's just a function that takes a matrix and multiply it directly. So with the for loops, there's really no magic behind that.
But the Python code, what it did before, it just it just passed the calculations to GPUs, and what the C code did, it just brute force implements all the algorithms on the C side.
So the Python side has these frameworks. You have some blocks which are already predefined. Okay, here multiply this, and then actually I think that even the whole transformer thing is already a block, so you don't have to do it. Almost like it's very simple because it's already done for you, right? So which I mean is very good, and actually these frameworks, they compile to many backends, so you can compile for the NVIDIA CPU, the AMD stuff, the AMD CPUs, even the regular CPUs, so they can actually get some parallelism for free. So even if you don't have to do it in the model themselves, but they can compile this graph to a more efficient version to run on your CPU, because it's compilers all the way down, right?
Yeah. Okay. And another question. So the Python code, which was ported to C, is it model specific, or is it like front end for all weights? So you know what I mean? Because if this is like if weights is the training data, can we reuse the C code, or is it very model specific?
Right. So that's the nice thing of this work that Capacity did. It was the Llama model is rather standard. Mm-hmm. Let's say like the compute graph that does the inference for this model is very well like defined and like standard. For example, Llama 2, so Llama 1, Llama 2, Llama 3, they share the same compute graph, the same model. So you can reuse the code to run like the previous llamas that from Meta, and with almost no difference. There's a few tiny differences in the way the input is tokenized and stuff like that, but actually the compute graph, the model that itself is the same. Other companies like Mistral, they also, it's a French startup, they have these also very good models. What they use is also very similar. So you can use this graph with a few tweaks, right? And you just plug the weights, the Mistral weights on the other side, and it just works. But yes, it's all this port is only tailored to Llama models.
But Llama could become almost a standard, right? Because there's Facebook behind.
I would say that it's already pretty standard and pretty successful in that regard. So yes, and actually you can plug any size of them. So because you have the 8 billion parameter, the 70 billion, 30 billion. So there's a bunch of different sizes of these models. And in this C program, and then in the port, of course, you can plug any of those. So the only thing that changes is that the model then uses bigger matrices and more layers, so like more computation. But other than that, it's the same. So it's the same compute graph, just parameterized with a tiny, like a few extra parameters.
Yeah, and in the weights there are more numbers, so therefore the more numbers, they are taken by the larger matrices, right, for the multiplication or whatever. So this is how we can understand the size of the model.
Yes, exactly.
And the quantization is like we can restrict more or less compression of the weights, right? So that we, with some smartness, we need shorter vectors to do similar work, right?
Right. So the idea with quantization is actually to reduce the size of the model. So because imagine that, so you can have your model, your weights in float 32, which is 4 bytes per weight. But if you can reduce that to like float 16, then your model is like half the size. So you can do 2x the throughput. But if you can quantize and then have 1 byte, I think it's one of the modest quantization you can do. Then you get 4x. But then there are more tricks. So you can do like compress every weight to 4 bits. There are tricks. You lose some precision, but these models are like resilient enough. So even if you encode every weight with only 4 bits, for something with 4.5 with bits, the models are still like sane. So they output like correct tokens and stuff like that. So if you go too low, at some point I've seen this, like the models just start spitting like garbage, random tokens and stuff like that, because, well, it's like doing like a brain surgery, right? So you are like computing, gutting the precision of the weight. But so the whole goal of quantization is actually maybe trade some compute, because the quantization, then you need to do extra work, but you have the compute. So the only thing you don't have much is that, so you're limited by the band.
But you could do it only once, right? The work.
Well, exactly. Well, depends, because, for example, if you want to do the vector API, you need to put the values into vectors. So if the value is just not read it from memory, you need to do some operations to actually load them, chip them, scale them, and then you have a vector, like a register, and then you can do the operation. So maybe you trade off a bit of compute in that regard by having a much lesser space per weight.
Okay. So this is why, the work in Java is Project Babylon and the others are interesting, because what they try to do, to introduce new data types, which are shorter, and this is exactly why you need them for LLM integration. But now you ported the Llama standard, which is actually exciting, because what it means right now, we have a Java way, which is compatible with all Llama models, and there's small tweaks, maybe even with Mistral, which is also very important, to load the weights of Llama to Java without any external APIs, right?
Correct. Yes. Actually, so the previous there was some holiday recently, and I ported the Llama 3, which is the latest model. So there was just a few changes, because they changed the way the prompts are tokenized and stuff like that. But the model remains the same. So I ported this Llama 3, and I'm working on some backend for, maybe you heard like LangChain4j. Yeah, I've seen your purpose actually. Yeah. Yes. So you can. So I'm writing the backend for this library, so you can use this Llama Java version to drive the whole API. Which is, it works. The API, the LangChain4j stuff is very, very nice. So I really like.
That is a huge news. What it means, we could have LangChain4j, which runs on Quarkus, which runs on GraalVM, and can be completely natively compiled, to an image, right?
Well, hopefully, the sad part is that the vector API, which is critical for this, it's not supported yet by GraalVM. So the Graal compiler, it does support some operations, but not the entire thing. So that's one of the limitations.
But it could happen, right? In one point.
Yeah, there are some operations already work. So, but let's say like the vector API is a moving target. Yeah. So, and I think that the so when Valhalla is actually done, then the vector API will then done, because now you have all this boxing, and it's just a compiler tricks. But yes, so once the vector API gets implemented in Graal, yes, for sure.
Yeah. Perfect, but LangChain, even now, LangChain4j, so it means we could have a pure Java implementation which talks to a model, right, without any external library.
Right, so that's what I'm doing. So exactly, so you can have a local model. So the entire thing runs entirely in Java. So your LangChain4j is the API, which is very nice, and then whatever you plugged on the backend on the other side is also a Java model. And one of the nice things with this approach is that then you have much more, let's say, access to the actual guts of the model. So, for example, you can customize, I don't know, the state, save, persist the internal state of the model, so you don't have to replay again the entire like prompt. You can just load it from memory or serialize and stuff like this. So if you had these models in Java, even if they're not very fast because it's only CPU, but they are like within 10% of compared to the C versions. So it's not that it's that slow. You still have more access to the guts of the thing. So you could then implement some extra functionality because in this C APIs, it's like a black box. So you have an API, but then what runs the model or the weights or the storage, you don't have access to it. It's just an opaque thing. But in this case, you could really hack the inference and hack a few extra aspects of the inference just to your benefit.
Yeah, and what's really good is because if you use it in enterprise, you will have to run it somewhere in Docker, serverless, Lambda, whatever. And whatever you're doing is always better to have pure Java because you don't have to deal, with JNI and whatever you have to deal with. This is just more stable. How long it took to port, the first initial idea so you were able to talk to Llama,
Right. So I spent a weekend doing this. I mean, the C code from Carpathy was actually very good and very. So I think it was not, let's say, not very short, but still was very well commented. And the operations were written in a way not to be clever, but to be explicit, and that actually really helped. I think that. After the first, what it did just to implement one by one, and then you start like tweaking and adding like more Java-like constructs. So actually, the port on itself was not that hard, but then adding these vector APIs and then getting into how this process worked. Actually, I enjoyed it a lot because it took more time, but actually, it's the nice part because you realize that actually it's not. Like a complex thing, right? So it's like I always joke that like the humanity always like chasing like God, like if it was in heavens or in some exotic place. Yeah. But actually, when you see these models, you can see, but everyone can understand how this works because you can understand every operation, every single bit of what's going on. You can see all the weights, right? But nobody knows exactly why it works and why it's so good. So it's like the mystery of the universe. I really have a great time going into these subjects. And also when you start doing this, then you start talking to the model because you want to try them, right? So I want to test how it does in math, and then you realize that so you multiply some matrices, and this program then talks back to you. And actually, that's also a very rewarding moment because,
I think what's really rewarding is that you made it work in Java. The first, how to call it, output from the model was exciting, that it works at all, right? Were you confident that it will work? Or you said, I'll try it and hopefully it works?
Well, I mean, that's part of so I had like some free time. So basically, I will have worked till it worked, right?
Yeah.
So, I mean, I was very glad that they worked pretty like fast, let's say. But the actual thing was like, I mean, it was complex enough to have some doubts, but at the same time, it just demystifies all the complexities and the things are around the magic around these models because this model is going to take over the world and all that stuff. But then when you realize what's going on, you say, maybe not, right? It's just a different perspective. But so it's not actually not that complex. And actually, at the core of this Llama stuff or the models in general is a very tiny, let's say, compute graph. The model per se, the actual value comes from the weights. That's the hard part, right?
Yeah.
So inference is kind of easy. So generating the weights and preparing the data to train with these models. That's where actually the very hard work lies.
Yeah, but the weights are there. It's open source is just bag of numbers, right? So this is the weights.
Yeah, exactly. So and you can I've seen this fine tunes from people like, for example, they teach the models to do function calling So your model then you can say, oh, I have a function that gets you the current time or the stock market and stuff like this. That's very nice. Yeah. And the model learns to call these functions, and you can create an API to do this.
The exciting part is you ported now Llama to Java, and we have LangChain for J. So what also available is JVector. I don't know what they are. JVector is this vector database completely written in Java and actually performs great. And it is also available in Cassandra, for instance. So we have now a full AI stack in Java, pure Java, actually.
Right. Well, so I would say that this port of Java is still not very fast because it runs purely on the CPU. But it's competitive with the C versions, the Llama CPP. Maybe not in all aspects, because the Llama CPP is really like a monster of many features. So whatever features you may imagine, like this Llama CPP has it. In this case, it's just a very basic. So the good thing will be to port this to somehow access the GPUs. So I've been trying to do something with maybe you heard like Tornado VM, something like that, just to from Java, from within Java, just access the graphics card. But let's say so for now it's CPU only. So
you had a chat with Tornado VM guys?
Yeah, of course, sure. There are some like technical hurdles, let's say, to run these models on Tornado. But I think the whole Tornado approach is very nice, and it's a good API to talk to the GPUs, just not entirely tailored for this particular use case.
You have to talk to Juan, because you had a chat with him.
Yeah, we talked last year in September, and actually they had a version of this port written for Tornado, so it's accelerated a bit by Tornado VM. But the idea is just not do it like partially, but try to plug more pieces of the inference part so accelerate with Tornado and then offload everything to the GPU, or as much as you can to the GPU.
Yeah, and you also had a chat for sure with Babylon guys, right? Java, because they also tried.
Not really. So actually, I heard of that from your podcast, and I looked some talks on the internet. And yes, so it's also a very nice approach to actually use Java directly so that you can do even more. So you can do what Python is doing today.
Exactly.
You can do exactly. So that will be like open so many use cases.
Yeah, this is what Paul Sanders is working. And I would say if I were your manager at Oracle, I would say go for it, because what you are doing, it would be, it could explode actually, because now, AI, all projects, large enterprise companies ask me about how to integrate AI, LLMs. And if there is a pure Java integration, I mean, then we are done, right? Because, okay, I zip everything to one thing and it works. And right now, without this integration, it is a mess, because, you have to use JNIC or whatever. There's always something in between. And we were there at the beginning of my Java work in enterprise. We had always to integrate, a C algorithms for insurance companies, where, all the math happened, and it was always a mess, because it was unstable. There were concurrency issues and garbage collector issues, and the pure Java approach is the way to go. So, and you are already there. I would say if the GraalVM, we could have a GraalVM AI edition, right? So this is a huge opportunity actually, marketing wise and added value. So ping your manager and say, hey Sean, I would do on vacations the GraalVM debugger, and during my work, AI. I think this would be huge. And Paul Sandoz also works on that, and maybe you should ping him, because he's really interested in use cases. I had a similar chat with him and say, hey, this is huge, because if we integrate it with Java, then we can optimize it. You can optimize it with GraalVM, and all the vendors can optimize it, and it will also push Panama forward for the new data types, right? For the quantization, whatever. This will be a huge move to Java, so we cannot ignore this. And we are almost already there with almost no effort. I mean, what you did was you said, they were just vacations or weekends. So it's not like a huge team, spend months to integrate that, right? So amazing. So now, how performant is it? You say 10% slower than C.
Yes. So there are many metrics for this. So one is the prompt evaluation is when you have this prompt and then you know the tokens and then you want to ingest them means like feed them to the model. And the other metric is the actual evaluation time. So like when the model actually starts doing the inference. So for now, this Llama CPP, so the prompt part is much faster. Usually it's like the instructions you give to the model. Oh, please give me like some answer related to the subject, whatever. So in my port, everything is the same. So basically we ingest the prompt by forcing the inference. So basically the inference and the prompt ingestion is the same code. So you can get in my machine, I mean, it's a workstation, you can get maybe 10 tokens per second. So this CPU only. In a server probably you could get more. So like depending on the bandwidth, because this thing has like 40 gigabits per second or something. So you're really limited by bandwidth. So if you have a server CPU like with 8 like RAND sticks, and then probably you could get more. But actually, so it's only meant for a chat stuff. It's not meant to generate like go crazy and like spit a lot of text and do things like that.
Yeah, but 10% is still amazing. And you ever tried it with Apple's M3 or M2?
No. So actually, I don't have any Apple machine to try it. I would love to try it because I know that the vector the instructions are different. So the whole vector thing is different on ARM. So I would like to see how the vector API does perform on Apple or on ARM hardware.
Yeah. So maybe to listeners, they can also try it. So what is exactly to do to try it out? So they will have to go to the repository. You put it in the show notes, but you can maybe mention what's the name of the repository.
So the one that is publicly available now is called LLama2.java. So you can just search it on Google or look up. And actually, it's almost ready to run. So you can. The only thing that one is is a straight port from Carpathic. So I try to keep as faithful to the original port because it's an educational value. So I don't want to go like crazy and start doing a lot of optimizations. I think that is for another project. So this other stuff I'm working on for the Llama 3, and actually I have a bunch of extra utilities to read from the different formats and do quantizations and stuff like this. It's not open yet. So I don't know. I'm working on this for some time already, but I haven't open sourced it yet. So for now, I think the LLama2.java is the place to go. You can run like smaller llamas, like models, right? Like speeds of stories, and you can feel the speed there. I mean, these smaller models, of course, like you can like get like, I don't know. In this machine, I have a workstation. I can get like 500 tokens per second. But these again are like much smaller models, so way less capable.
But there's only one class, right? So everything is written in one Java class.
Yeah, so it's like 1,000 lines of Java. So and there's no fancy, clever anything. It's just literally for loops, matrix. Well, in this one, there is vector API for the matrix multiplication because it gives like a 4x speedup. But yes, it's just a one method, and it's confined to that one. Everything else is just like doing the inferencing and small like command line utility, so you can specify some parameters.
And so I will have to clone it and run it, read your extraction, it run it, right? We need Java 22, I assume, right? And
I think Java 21 because you need. I think the Panama was because the way we do it, just you memory map the weights to direct to native memory. So you don't have to load them and read them. And that's actually much faster. So you run it once, the first time it was going to be somehow slow to start, but once the weights are cached, if you have enough RAM, then the second time will be instant.
Yeah.
So that's very nice. So yes, Java 21, just clone it and that's it.
And is there any like a benchmark so you get the numbers out so you can report back to you and say on my hardware was that fast or?
Well, not really. So because it varies depending on your machine, and so even for example, if you run it on a laptop, depends on which cores of your laptop you're using.
Yeah.
Because like these Intel new CPUs, they have the efficiency cores.
Yeah.
which are not that great. Let's say like, or they have these performance cores. So it depends really on which hardware configuration you run it. So it's very hard to report any data. Actually, I've seen people on Twitter saying like, "Oh, I got this token per second or something," but this measure is not very meaningful because it's very hard to equate with the measurements I've done myself.
But let's say Tornado VM or Babylon will work, and with Java we got a nice access to GPUs. So then this Java pod will be faster than Python and C, right?
Yes. Well, hopefully, let's say so. One of the bottlenecks of the models sometimes is Python itself. So Python is not fast enough to feed the GPU or something like this. So these frameworks, the way they combat this issue is like the entire model, the entire graph is compiled to something else, and then that something else is what it actually executed. So Python has very little. So maybe the first time you run it, it will like construct the graph and the complete graph, and then just compile to something else. In Java, this just like an order of magnitude faster. So this problem of Python is really not there. You can really feed the GPUs, at least the basic, the commands, very fast. What is missing, which Python has, is a very nice they say like the frameworks provide a very nice APIs for the GPUs, very nice abstractions. In Java, I've tried a few libraries like this. Was JCUDA, but anyway, it's just tailored to NVIDIA GPUs, or there was always these limitations. Mm-hmm. There's no API to actually abstract the GPUs from Java, or at least there's not the general API. I think Tornado VM is one of the promising candidates, but mm-hmm. still for some tiny technical reasons, the porting the inference to Tornado VM is still not possible. Yeah, this all I think can be solved. It's just a matter of time.
Yeah, this is a crazy that Oracle doesn't see this. Paul Sanders is very far. You are very far. A little bit more resources, and we had a decent solution, right? With a very small team.
Well, I think so. If you have the pieces, you manage to implement the right pieces. I think you can build even around Tornado, for example, a nice API to talk to the GPU in a generic way, because that's actually important. So you can run on any device you want. So you can run on NVIDIA, on the CPU, or whatever. It doesn't matter. Mm-hmm. And actually, so I've seen that the way Tornado VM works is very nice. So the API is very well designed and very concise. For the use case, it's a bit overly restrictive. So maybe we need some extra freedom to do it, but ideally it can be done. I think the Tornado VM guy is also working on something like this, so to port the models to Tornado and run the whole inference in Tornado, but I don't know what the status of that.
Yeah, this is what they told me, that they have a startup to integrate AI with enterprise, and this is Paravox AI is the startup from them. Yeah, exactly. Paravox AI. Hey, empowering Java for AI and data analytics. This is the startups. Okay. Hey, great news. So I have to reinvite you back, because what I'm interested is now in two things. What Llama 3 is doing, and the second part is Espresso. If you're back to Espresso, also exciting stuff, right? So what they are doing is Espresso there. And maybe last question, the LLama thing is nothing else than you just packaging everything to a Docker, right?
Right. So LLama is a wrapper around Llama CPP. So they offer a nice package or nice APIs around this open source protocol, Llama CPP.
Yeah, exactly. This is what I also saw. Alfonso, where people can find you, where they can donate on MacBook Pro M3, how can they send you hardware to support you? So what's your Twitter, Blue Sky, or whatever handle?
Well, I have a Twitter, but I don't use it much really. So it's called like the Mukel, so MUKEL, the Mukel. But I really don't use it much. You can find me on GitHub, GitHub /Mukel, MUKEL. there I think it's on my email or something, so you can find me there.
GitHub Mukel. Okay.
Yes, correct. So that's my GitHub, my like go-to place to find about me, and that's it. So I mean, this whole AI stuff is very cool, right? It's like so many people interested in it, but it's very hard to get people with the same mindsets to be together and discuss and so on.
Yeah, but you did something hands-on, which is a new tangible 1,000 lines of Java code, and a native integration, which is amazing. So writing a huge framework is one thing, but writing one file which works is another. So really amazed, and thank you for your work.
Yeah, let's hope. I mean, I really enjoyed the entire thing. So like the process of porting it. So it's very challenging and rewarding. Let's see how it works in the future. If it can be something else, it can be a project converted into some
Yeah, it will. So I'm pretty sure that it has to actually. So because the entire enterprise, everyone waits for it. And I was in several companies recently, and they didn't even knew that this is possible. What you did, that you could say we can have a local model. Oh, this opens complete new worlds to fraud detection or whatever. And they have huge Java systems, and I mean this is the use case is huge, because this is what we are talking. Closed model which belongs to you, nicely integrated, which is robust, no external dependencies, and here we go, right? So this is what everyone waits for. So I would say the opportunities are huge. So. You should, create your own company, and then you have your own. It will start after a few months with a small Tesla, and then maybe a yacht, and then a castle somewhere.
Well, I really enjoy my day job.
Yeah, just kidding. So just fun.
I'm pretty sure I'll stay around for a while.
This is just to your manager. Give him a little bit, a little bit more resources to chase, AI. So to Thomas Wüttinger, I have to talk with him. So if he's the master of universe at GraalVM. Thank you a lot, and see you next time.
Well, thank you, Adam, for inviting me. It was very nice. I enjoyed it.